All right, ladies and gentlemen, yes.
I don't have to class.
Did you look at the chapter 8 practice test? That's where it's under. So it pulls up. All right, ladies and gentlemen, let's start back in section 4.1. By the way, this says chapter 8, but that's because we're in unit 8. It's actually chapter 4. Shh, up here, please. It's actually chapter 4 from your book. Katie, Sam, Wyatt, okay.
Oh, sorry.
Okay, and we're going to start reviewing. This is from section 4.1. You will notice that 3.6 is not on here. 3.6 is what you guys had that quiz on, and you could turn in quiz corrections. I'm still grading those. That is going to be on the final. It will not be on the chapter 4 test. So what you see on here is what you need to be prepared for on Wednesday.
Got it.
All right, let's go back to 4.1. 4.1, we learned about exponential functions. Exponential functions come in the form y equals a base a to the x power. What would be the parent function from number 1? Y equals, Lydia, do you know it? 3 to the x, awesome. Now, once you know the parent function, you can pick out 3 parent points to help guide your shape. What do we plug in for these, Wyatt?
Yeah, what you said, but is the parent function, it's always the first number.
So you basically, to ever find a parent function, you take away anything that's been plus or minus.
So the next one would be like y equals 5 to the x.
Well, take away the -2.
5.
Yep. Okay, so as I plug this in, I would have 3 to the 0 power would give me 1. 3 to the first power gives me 3. 3 to the -1st power, what does that become? 1/3, awesome. So when I graph these, I would have -1/3, 0, 1, 1, 3. This is my parent graph, and hopefully this kind of reminds you that all the points approach 0, but will they ever reach 0? No, which is why we have an asymptote at y equals 0 for all, God bless you, parent graphs of exponentials. Then, looking at the equation, how will the x minus 2 affect this graph?
Right to.
Good, right 2. And the +1 will be up 1. Awesome. So we're going to take each of those points and move them right 2, up 1, right 2, up 1. I'm going to take that point, which is at 1/3, and go right 2, up 1. And all of these points will no longer approach 0. What will they approach instead? 1. Good, because everything's been shifted to the right and up. So since it's been shifted up, all of those points move up, which means I have a new horizontal asymptote, not at y equals 0. What is the new one at? Good, y equals 1. Now, be careful. On the test, I will ask you to label it as the equation of a line. So how would we label this? And it's shown that way on your practice test as well. It asks for it as an equation of a line. When it says the equation of a line, you want to have either y equals or x equals. If it's a horizontal line, the equation is always y equals. So you might want to give yourself a little note. I know a lot of people forgot that when they were working through the homework or kind of some practice things we've done. But the equation of a horizontal line is y equals a number. All right, on to number 2. Number 2, let's do the oldest in the group. You share what the parent function would be.
Parent function is y equals 5x. 5 to the x.
What about the negative?
Take it away.
Yeah, smarter student.
You guys are
You said
so.
no.
I can't say one is smarter than the other. I couldn't even judge that by a grade. That doesn't measure your aptitude.
I think since I got a 97 in my final answer, I think that's
No, I think
What's your grade right now?
see, I think everybody's smart in their own way. I never call one person smarter than the other. All right, guys. Your parent graph. Lydia, did you have a question?
Which?
This is the in-class review.
It's
Ours is
that
different.
that one's the
Yeah.
practice test.
Ours is
They do the
log.
practice test.
Ours is log, base 5.
You guys grabbed the wrong one.
You have the wrong one. No,
You have the practice test.
Well, I might have the wrong one.
No.
You're doing
You
the
have to
practice.
Okay, the practice test is way shorter.
Yeah, that one's different though, the two is different. It's not.
So the in-class review, you want to make sure you download the one that says in-class review, not the practice test.
Yeah, we did.
And it says different?
Yeah, it is. You're doing the practice.
We'll just change it to a Y.
Hold
The
on.
last question for ours is.
No, this should be the in-class review. Unless, did I mislabel it? Because I did, I mean, I'll be honest with you guys, I created the practice test from the in-class review, so I might have mislabeled it, but let me see, the practice test should look like this. Chapter 4 practice test, and it should have a log base 3 of x minus 1.
No, ours is log base 5.
What do you guys have? I'm so confused. Okay. Un momento. And this is for the people who downloaded it from on campus, right?
Yeah.
Can I just give you guys paper for now and I'll fix on campus? I'm not sure what is on campus. I'm really confused. But this is what was supposed to be for the test review. Wait a minute, almost I copied the wrong thing.
The first one is right.
All right, well, this has better practice on it, so if you guys are okay with that, I'm just gonna like. This-
Oh, wait, no. Wow. Wow.
No, I did download the wrong one. Oh, shucks, you guys are right. But you know what? We'll stick with this and I'll skip the 2 that we don't need, okay?
So
Um,
on our surface area.
just stick with this one and, oh man, this is really, I messed up. You guys are right and I copied the wrong thing. I'm sorry, but now we'll just keep going with this and then, no, I copied the wrong thing. They had the right thing, but it's okay. It's good practice either way. This isn't homework anyway. This is meant to help you review.
Well, can we keep going?
Yeah, let's keep going. Okay, so the -1, and I'm sorry for the confusion, guys, that would go down 1. What will the negative do?
I don't know.
Good, which axis?
No.
Over the X, it's gonna go upside down. So, and always reflect first. So I'm gonna take that point, move it down, take that point, move it down, take that point, move it down, 1, 2, 3, 4, 5. The reflection always happens first, but then I need to take each point and move it down 1. So I'm gonna take this point, which is at 0, -1, move it down 1. I'm gonna take 1, -5 and move it to 1, -6. -1 1/3 is now going to go to -1, -1 1/3. And all of those points which were approaching 0, what are they going to be approaching now? -1. So my final graph is in green for me. What would be the equation of the asymptote?
Y equals -1.
Nice. All right, let's go down to number 3. Number 3, get rid of the pluses, the minuses, anything multiplied in front, and that will tell you what your parent graph should look like. What should be my parent graph? Y equals log base 6, good, of X. And if I'm thinking about log base 6, do you guys remember which point always lies on a parent log graph? No,
Oh, 1.
1, 0, good. So if you think about exponent graphs, those always have the point 0, 1, but log graphs always have the point 1, 0. Then, do you remember what other points would be good to plug in for a parent graph?
Negative.
Match the base. So you could plug in 6. What should come out if you are evaluating log base 6 of 6? 1. And what's another good point to plug in? Nice, 1/6. What will come out? -1. Awesome.
Oh, yeah.
It's like the opposite of the exponential graphs. So I'm going to have 1/6, -1, 1, 0, And 6, 1, 2, 3, 4, 5, 6, 1 kind of goes off. But then the log graph looks like this. And how will the -1 move the graph? Good, right one. So I'm going to take each of those points, move right one, move this one, I'm sorry, it goes off one, right one. And the shape continues in this way. The vertical asymptote used to be at x equals 0. But now that it moves to the right one, awesome, it's going to be at x equals 1. So I can go ahead and write down that asymptote will be at x equals 1. All right, try the next one on your own. See if you can determine the parent graph, good points to use. Number 2 is y equals -1. Because if the negative is inside with the x, it goes over the y-axis. If it's outside the operation of the x, it goes over the x-axis. All right, ladies and gentlemen, check to see that you had the graph moving over the y-axis and up 2. Your asymptote should be at x equals 0. And the good points to use to move would be 1, 0, 5, 1, and 1/5 -1. Something that's also pretty helpful to make note of, for all exponential graphs like numbers 1 and 2, the location of the asymptote will be the number on the outside of the equation. Notice -1, -1, notice 1, 1. For all log graphs, the location of the asymptote is the opposite of the number in the parentheses. So here I see x -1. Notice the location of the asymptote was x equals 1. And if I look at this log graph, there's nothing being subtracted from x, so it shows up at 0. Just helpful kind of cues to make note of. Okay, number 5 and number 6, the rest of the chapter really hangs on these 2 facts. Do you know how to convert from exponent to log form and vice versa? So let's see if you guys remember. Number 5, if I'm converting it to exponent form, which one's the base? 2, good, so drop the base. And what should be the exponent? 10, good, is equal to x, that's it, we're done. Number 6, can you go the other way? So now I'm converting it to a log. So I would have log, what's the base of the log? X, good. Of what? N equals? Perfect. And that's the answer. All right, on to 7 through 12. There's a few rules that are helpful to know, actually not always necessary, but if you know log base x of x to the y equals y, that's often pretty helpful. Something else that's important or that's really helpful to know is that log base x of 1 always equals 0. And then some rules that we've had to review along the way is that any number to a negative exponent puts the number under 1. And there was another helpful rule to make note of. If you had it to a fraction, that was actually a radical in disguise. These were learned back in chapter P, but they're helpful for evaluating certain log expressions. Okay, so number 7. Number 7, you could go about it using the rules, or you could go about it just converting to exponent form. Yeah. If it lets me. Yes. Okay, so Mario just noticed one of the ones show up really quickly as the rule. Number 12, what is log base 4 of 1? 0. So if you know the rule well, you don't have to do any conversion, just that's it. Lydia.
The number 9, is that going to be a fraction or a negative?
It's going to be a negative exponent.
And how do you know?
You know that because 1 over 8 is actually 1 over 2 cubed. And based off of one of the rules from the previous chapter that we would want to be aware of is 1 over 2 cubed is the same as 2 to the negative third.
Oh.
Do you see that?
If I put like 1/3, is that the same?
No, sadly, it's incorrect. So the answer does have to be negative 3.
Oh.
Now, if you wanted to look at it, so this is one way, or you could go about this way. You'd say 2 raised to what power equals 1/8. But you still have to recognize that that number is going under 1. So I know it has to be a negative power. And then I just have to be aware that 8 is really 2 cubed. So that's where I get that negative 3 answer.
So when is it a fraction?
When it's in a fraction, you know, basically you're going to have a negative answer, typically.
Oh.
All right, guys, number 7. Were we able to determine number 7?
4.
4? You could have asked 2 raised to what power gives you 16? Or you could have looked at this as log base 2 of 2 to the 4th has to give you 4. Number 8. 5 raised to what power gives you 125? 3, which is correct. Or you could have looked at this as log base 5 of 5 cubed. We'll spit out 3. Number 9 we did together. Number 10. 27 raised to what power will give you 3? So you want to think, yes, 1/3, because the cubed root of 27 is 27 to the 1/3 power. So in this case, the answer is 1/3 because of really that fact. Or the way that we originally looked at it in class is 27 is 3 cubed. And then you could say 3 to the 3x has to equal 3 to the first. We looked at once the bases are the same, the exponents have to be the same. So you can set 3x equal to 1 and then still determine that that's 1/3. Either way, you need to know it's 1/3. All right, number 11. We've actually been doing this in our graphing setup. 7 raised to what power will give you 1/7? Negative 1. And again, that's, you could use the rule that log base 7 of 7 to the negative first gives you negative 1. All right. Properties, the product, the quotient, and the power. Something that's important for you to make note of. When you're combining logs, you want to use the power property first. When you're expanding logs, you use the power property last. Otherwise, work left to right. So if you want to write down kind of a little memory cue when to use the power property, when to use, because that one actually has an order that's particular. When combining, you use it first. When expanding, you use it last. Mr. Felinsky used to teach Algebra 2 with me, and the acronym that he made out of that is Coach Felinsky Eats Liver. I don't remember why. I don't know if he actually eats liver, but we used it all the time when we taught Algebra 2 together to help students remember when you're combining logs, use it first. When you're expanding, use it last. I don't know why, but since hearing that acronym, I just can't think of anything else to do CFEL. Okay, so with that said, looking at number 13, are we combining the logs or are we expanding them out? Combining. So what do I need to do first? Use the power property. Put the 3 up to the x. So that would give me natural log of x cubed plus natural log of z minus natural log of y. Then I just work left to right. So how do I bring 2 logs together if there's a plus sign in between? Multiply. Awesome. And I multiply these 2 numbers. So that will give me natural log of x cubed times z. And then I still have minus natural log of y. And then if I have a minus sign, how do I bring those together? Division. And I want to divide this number by this number. So now, as a single log, this is going to become natural log of x cubed times z divided by y. And that,
What if I wrote like ln on top of bottom? That's wrong.
yes, so it has to be a single log. Also, guys, what else could you have this instead as? What is ln? Yes, you could have log base e of this, and that's still correct. Okay, number 14. 14 says use the properties of logs to evaluate, which means determine the value. So basically, once you get it there, solve it. Once you get it to the end. So number 14, I want to combine these into a single log. What am I going to have to do first? Good, move the 2. Make sure we do the power property first. So that'll become log base 9 of 36 minus log base 9 of 2 squared. What is 2 squared? 4, awesome. So I have, now what am I going to use to bring these 2 numbers together? Division. So I'm going to do 36 divided by 4. And that'll become log base 9 of 36 divided by 4. What is 36 divided by 4? 9. Now determine its value. What is log base 9 of 9 equal to? 1. All right, on to the next one. And cross off number 16. I ended up taking that one off on the actual review, which is why I know I copied the wrong review, but just take off 16. Number 15, go ahead, try 15 on your own. I'll walk around, kind of see. Because you're asking 9 raised to what power gives you 9? And that comes out to be 1. All right, guys, go ahead and take a look. Make sure you use the power property first, which would create a 4 cubed and a 2 cubed. 4 cubed is 64, 2 cubed is 8. Then we would use the division operation to get log base 5 of 8. Then we'd use the multiplication to get 8 times 1/8, which is 1. And then evaluate 5 raised to what power would give you 1. That answer would have to be 0. Any questions on that? All right. Next, we solve for exponential equations and logarithmic equations. Number 17, notice this is still on the non-calculator part of the review. We haven't touched our calculator yet, nor could we on the test. So with that said, number 17, if I can't use the calculator, what am I going to do here? Make the bases the same. Awesome. So this base is 2. How do I write 8 as a base of 2? Good, 2 to the third. So I replace 8 with 2 to the third, and then that's still raised to the 2x plus 1. The other side, the base is still 2, and I have it raised to the x minus 4. What do I do with this 3 raised to the 2x plus 1? Multiply. Awesome. So we're going to have 2, supposed to be there, 2 raised to the 3 times parentheses 2x plus 1 is equal to 2 raised to the x minus 4. Once the bases are the same, the exponents are the same. So you could try to, if you want, or up for a challenge, you could think what number minus 4 would equal the same number as 3 times 2 times that value plus 1. That's hard to think in our head. So what we typically do is just recopy the exponents and set them equal to each other and then rely. Yep, distribute that through, which is an important step. 6x plus 3. And then we'll solve for x. So we would subtract x.
What? 2x minus 1?
2x plus 1.
Oh,
And then we have negative 4 is equal to 5x plus 3. We'll subtract 3 from both sides, giving me negative 7 is equal to 5 times x. Divide both sides by 5, and that would leave us with negative 7/5. Number 18, go ahead, try this one on your own. Subtract 1 over 2.
so you could do it. I'm probably cross that out. Just copy it and see what that was like plus. Yeah, sorry.
And so,
All right, guys, you should have had 5 to the negative first is the base we would want to create for the left side. 5 squared is the right side. So when I copy those exponents, I want to distribute that negative 1. So I'd have negative x minus 1 equals 2. I'd add 1, giving me negative x equals 3. Divide by negative 1, so x should take on the value of negative 3.
Wait, actually,
Yeah.
so don't you divide, it's like a negative x, you divide by negative x. So like,
You divide, it's actually negative 1 times x. Because it's the opposite of x, so it's the same thing as saying the opposite of 1 times x.
so I just get the negative one.
You would just divide, yep, both sides by that negative 1. All right, guys, now we can use our calculator. Skip 19 and 20. I apologize. That was not supposed to be on there.
Is it gonna be on the
Oh, no.
test? Hey.
21 is very similar to the one that we just did. So cross off 21. And now I want to go to 22. 22. The variable is in the exponent. What is the only way to solve when the variable is in the exponent? Put it in log form. So I'm just going to convert it. Log base what? 2 of 10 is equal to 2x plus 3. Awesome. Close. I need to isolate x. Katie?
Wait, why is it doing it?
Oh, good question. So the reason I can't do this one like the previous ones is because 10 can't be written as 2 to some power. So if you can't use the same base, you have to use a log. Great question. Okay, now to get x by itself, what am I going to do with this plus 3? Good, minus 3 from both sides. Can I do 10 minus 3 and call this a log base 2 of 7? No, log base 2 of 10 is a decimal answer. I told you guys put parentheses around it so that you know it can't be touched. Like you cannot subtract from within it. So we have log base 2 of 10 minus 3 equals 2 times x. Divide everything by 2. If I ask you to leave this in exact form, this would be your answer. But if I ask you to round, and I will usually ask you to do both, you want to make sure that you know how to plug this in. So we want to make sure we start off in a fraction. And do you remember how we access the log? Alpha window, good. Option 5. So we would do log base 2 of 10. Is it minus 3 divided by 2?
Yeah.
Thank you. Minus 3. Yep, 0.161.
Is that, do you say like x equals?
Yep. So you would say x equals 0.161. And that's what it would be in exact form and rounded. Okay, on to a few more. Number 23, we have a similar situation, but I have to isolate the base before I can convert it. So number 23, which one's the base? E, I have to isolate that first. So basically get the e to the x plus 2 by itself. So good, I'm going to subtract 10. Giving me e to the x plus 2 is equal to 7. Now, what do? Log, good. What's my base? E of 7 equals x plus 2. I do not want to type in log base e on my calculator. What could I type in instead? ln, awesome. So that's a really important thing to make note of. Log base e is the same as ln.
Wait, isn't the problem like when you plug it in, it's like there's another exponent?
Yeah. So we would have natural log of 7 equals x plus 2, and then we would subtract 2 from all sides. And that would give me natural log of 7 minus 2 is equal to x. Lydia?
Wait, why do we have to change this?
Because log base e is really too hard to type. Log base e is the same as ln.
Oh, so then when do we change ln to e?
When it's given to you in the problem.
Oh,
Don't change it to e, change it to a log base e. So like number 26, I would change that to a log base e.
oh,
Okay. Okay, so in the calculator, we would want to make sure we would type in natural log of 7 and then minus 2. Right? Was that what?
Oh, you don't put it in the log?
Nope, don't put log base e because it's the same as ln. And then you can type that answer in, and that would give you negative 0.054. All right, number 24. If something's given to you in log form, what do? Switch it. That's basically the moral of the story of 4.5. If it starts in exponent form, if you can't solve it by hand, change it to log form. If it starts in log form, change it to exponent form. So how do I do that? What number would be the base? 5, good. What power would I raise it to? 0 equals, good, 10x minus 3. What is 5 to the 0? 1, so I have 1 equals 10x minus 3. And then I would add 3 to both sides, giving me 4 is equal to 10 times x. Divide both sides by 10. And x would equal 4/10. Can I reduce that? 2/5. Nice. Okay, skip 25 for now. Go to 26. 26, what would I call out just because of time's sake? we might come back to 25. Good. ln is the same as log base e. Here, I definitely want to switch it so that I can solve this through. Now, what would be my next step? Well, how do I get that x by itself? What can I do to get rid of a log?
Put it back.
Put it back into the other form. So the only way that you can get rid of a log is if you put it to the other form. So I would drop the e, raise it to the 4th power is equal to 8x squared. Divide both sides by 8. No, you got to get rid of the log because x is part of the log. So then we would have x squared is equal to e to the 4th over 8.
You have to square root it.
Yep, I have to square root it. And what do I have to keep in mind when taking a square root?
I don't know.
You need to do both to the top and the bottom, plus or minus. Do the plus and minus work here? Yes, because when you put it back in and square it, it will maintain a positive value of a log. So on my calculator, I'm going to determine what is the square root of e to the 4th. To access e, you press second ln, e to the 4th over 8. And I want to make sure I include the plus and the minus answer. So it'd be 2.612 and negative 2.612.
How do I do like the
Put in a fraction so you can go alpha y equals, and then n over d would give you numerator over denominator. And then guys, there's one more I want to get to before you guys leave here. Cross off 28 and write this down. Log base 4 of x plus 3 plus log base 4 of x is equal to 1. Log base 4 of x plus 3 plus log base 4 of x equals 1. I'm just going to walk through this. There's a plus sign, so I have to use the product property. So that would give me log base 4 of x times x plus 3 is equal to 1. The only way to get rid of the log is to convert it to exponent form. This is one you missed because of the scavenger hunt, so I would kind of just watch here. We need to get rid of the log, we convert to exponent form. So we'd have 4 to the 1st equals x times x plus 3. And yes, we're going to distribute x to x plus 3 to give us x squared plus 3x. Now here's the key. How do I solve something squared or a quadratic? Factor, set it equal to 0 and factor to solve. So I would subtract 4, giving me 0 equals x squared plus 3x minus 4. The last term's negative, so am I going to have the same or different signs? Different, giving me x and x plus 4 minus 1 would work to add up to 3. I'm going to get x is equal to 1 and x is equal to negative 4. Which one do I have to throw away? The negative. Why? That's correct. Awesome. I can't take the log of a negative. So here, x cannot equal negative 4, and my only answer is 1. All right, guys, practice test is homework. When is it due? Wednesday. When is your test? Wednesday.
You have practice tests and paper?
Yeah, it's underneath those.